Alright, so next up we have a function f of x equals x minus 1 over x plus 1. And we want to find the c guaranteed by the mean value theorem on the interval from 2 to 3. Now really we should double check that f of x satisfies the mean value theorem, the hypotheses. And the hypotheses were, is f continuous on 2, 3? And just to double check, the only part where we have to be careful is that x equals minus 1, and that is outside of the interval, so that's a check. And then is f differentiable on the open interval from 2 to 3? And again, the answer is yes, because the derivative, again, will have that x plus 1 squared in the denominator. Good. So now let's go ahead and write down what the mean value theorem says. It says that f prime of, there is a c such that f prime of c, or the instantaneous rate of change, is equal to the average change, right? Or average velocity and instantaneous velocity, if you like. Good. So we have a few things to compute here. Let's see. What is f of 2? And then we'll compute f of 3. So it looks like f of 2 is going to be 2 minus 1 over 2 plus 1, which is 1/3. And then f of 3 would be 3 minus 1 over 3 plus 1. Is that 2/4 or 1/2? Good. All right. And then let's see, f prime of x we'll just have as the quotient rule, derivative of the top times the bottom minus the top times the derivative of the bottom divided by the bottom squared. And so it looks like that's going to be x plus 1 minus x plus 1. So x plus 1 minus x plus 1. By the way, remember your parentheses here so we make sure all of our negative signs are right. So the x's cancel and I'm just left with 2. So that's going to be 2 over x plus 1 squared. Good. And so therefore, plugging these in, I get that I'm looking for c such that 2 over c plus 1 squared is equal to, let's see, f of 3 was 1/2 minus 1/3 divided by 3 minus 2. Good. Alright, so that's just going to be 1 in the denominator. In the numerator, it looks like we get a 1/6. Good. So 2 over c plus 1 squared is equal to 1/6. So if you cross multiply, you get 12 is equal to c plus 1 squared. Good. So therefore, c plus 1 is equal to plus or minus the square root of 12, and c is minus 1 plus or minus the square root of 12. Good. Now you do have to be a little bit careful here. We want to check to see what these values are. So if I plug these into my calculator, I see that c is approximately 2.46 or minus 4.46. Right? And so now if I look at my interval, the interval was 2 to 3. So therefore, one of these is not the c. The c value then is going to be 2.46, approximately 2.46. Very good. All right. So I'll pause for a second and we will write down the next problem. Alright, so this is 5b on the review. F of x is equal to x times the square root of 6 minus x. We want to know where f is increasing or decreasing. Where is f concave up, concave down? And where are the local or global extrema for f? And by the way, before we get started, maybe we should take a look at the domain. Since we have a square root of 6 minus x, that means that x is going to have to be less than or equal to 6, right? Good. Okay. So let's go after the derivatives then and see where they are positive or negative. So f prime of x, you have to use the product rule. So derivative of x is 1 times the square root of 6 minus x plus x, and then 1/2 6 minus x to the minus 1/2 times minus 1. And now we should probably simplify that. Square root of 6 minus x plus, let's see, I have a minus sign here. Minus x is going to be in the numerator. Looks like in the denominator I'll have a 2 times the square root of 6 minus x. Good. And so now I think I will go ahead and get a common denominator as well. So I'll go ahead and multiply both sides by, or top and bottom of this guy by, equals 2 square roots of 6 minus x there. Right. So that's just getting the common denominator, and that simplifies this expression quite a bit now, because that's going to be 2 times 6 minus x divided by 2 times the square root of 6 minus x. Good. All right. And so that looks like it's 12 minus 2x minus x is 12 minus 3x divided by 2 times the square root of 6 minus x. All right. Good. Now, before we, well, I guess we could go ahead and do this now. So in order to determine where f prime is positive or negative, we look at a number line. And let's see, our domain is x is less than or equal to 6, right? And then look for critical points. 6 is one critical point. That's where the derivative is 0. So we do have a critical point here. And then the other one is where the numerator is equal to 0, and that is at x equals 4. Good. So if where is f prime positive or negative? This is just the x-axis here. If x is less than 4, so suppose that x is equal to 0, then my first derivative is positive, right? And then when x is between 4 and 6, it's going to be negative. And so therefore, we can see here where the function is positive, or where the derivative is positive and where the derivative is negative. And we also see that this x equals 4 is critical point. And because we have positive and negative right here, we can see that that is both a local maximum and a global maximum, right? Because it's going to be doing this kind of routine, right, for the entire domain. Good. So that, so I'm using a sign chart, right, for the derivative here. And so that's why I wanted to bring this one up, because you may have to do a sign chart like that. So now that we've got the first derivative, let's take a look at the second. And the second derivative may take a little bit more algebra, but let's see if we can get our way through it. So I'm using the quotient rule here. I think I'm going to take out that 1/2. I could take out the 3 as well. Should I take out the 3 as well, just to make it a little bit easier? So I don't have to deal with that. Right, and so that's going to be 4 minus x on the top, divided by square root of 6 minus x on the bottom. And so now if I differentiate that, 3/2 just comes out. Derivative of the top is minus 1. Derivative of the bottom minus the derivative of the bottom, or let's put the top in first, times the derivative of the bottom. So that's going to look very familiar, right? All divided by the derivative of the, or sorry, the bottom function squared. So that's just going to be 6 minus x. Good. Now, when I'm simplifying, I think I'm going to bring the 6 minus x out here as well. Let's just kind of put that out here for a second while we deal with the inside. And so dealing with the inside, it looks like I've got 2 times the square root of 6 minus x in the denominator there. So maybe I'll work with that term first. That's going to be 4 minus x divided by 2 times the square root of 6 minus x, right? Oops, did I put my minus 1 in there? I did not. Were you yelling at me to do that? I'm sure you were. Plus. Okay. And then here I'm going to go ahead and do that. 2 times the square root of 6 minus x over 2 times the square root of 6 minus x again. Right, so that's going to be minus 2 times 6 minus x over 2 square roots of 6 minus x. Good. And now I think I've got everything lined up appropriately here. Let's see, I can take out that 2, so that would be a 3 over 4 times 6 minus x times, and then up on top I've got minus 12 minus 2x plus 4 minus x, all divided by square root 6 minus x. Good. I think things are coming together now. So hang on there, hang in there. Let's see, that's going to be 12. Is that going to be minus 8? And then minus 3x divided by the square root 6 minus x. Oop, I see a boo-boo. Were you yelling at me through the camera there? When I take minus 2 times those two, do you see where the error is? I should have a plus 2 right here. So sorry about that. So plus 2 minus 1 is going to be a plus 1. Good. And now I could leave it in this form if I wanted to, or I could bring it together. Just for fun, we can maybe 3/4 times x minus 8 divided by 6 minus x to the 3/2 power. Good. Now, where's the function concave up and concave down? Well, up in the numerator, you can see it changes sign at x equals 8. But what's the problem with that? Did you say that our domain was just these numbers from 6 on down? If you did, then you were right. So the 8 doesn't matter. And so therefore, if x is less than or equal to 6, is our function concave up or concave down? Well, 6 minus 8 is going to be a negative number, and then 6 minus a number less than 6, that's going to be a positive. So it'll be negative over positive, concave down everywhere. Good. All right. And so I think we've answered the questions now, right? So here's increasing is where x is less than 4. Decreasing, x is greater than 4. Concave up, concave down everywhere. In fact, concave down for x less than or equal to 6. Local extrema at local at x equals 4, and that's actually the global max too. Right, and that came from our graphical analysis right here. Very good. I went over on that one, but I wanted to get the algebra all figured out. All right. Good. Let's see. Well, I guess we'll just go ahead and continue on. We'll try a couple more problems and see how they go.